We all ready? Cool. Well, obviously, I love being up here following Eric. That's awesome. Thanks, Eric. It always reminds me of when we run a PDC or something like that, there's a session slot that everyone refers to as the Anders slot. And if any presenters get put up against Anders in that same time slot, we hear hell, where they're just like, move me out of this slot. So that's what I kind of feel like following Eric. Let's get this out of the way really quick, especially with the first slide of Eric. I'm an amateur. I'm not an expert like a lot of you guys in the room. I'm relatively new to actually digging into programming languages and really enjoying where I am. So here, I just want to dig into some of the F# stuff and how much I've enjoyed using F# as a vehicle in which to do language-oriented programming or to design programming languages where the implementation is actually using F# under the hood. I want to actually show you a couple languages that I put together over the weekend. Sorry, Eric, I know I should be waiting 10 years before I write any more programming languages, so I'll make sure not to do that again. Excuse me, a very simple one. I mean, we all know BASIC. I know a lot of my friends grew up with BASIC. Something very simple. We can go ahead and run this. Not entirely sexy. We can do other stuff. Let me open up some other files. We can do some recursive stuff and recursive functions, and that all works. We have the first 10 digits of Fibonacci. It gets particularly interesting if I go ahead and open up some higher order stuff. So the Lisp heads in the room may actually recognize this pattern of a function that has an embedded function that calls back to actually do the iteration all recursively. Something very simple, and you can see first-class functions where a function actually returns a function that then is passed in. If I go ahead and run that, very simple, works. What I love is under the hood, the evaluator that actually implements this language that actually runs is only about 45 lines of F# code. That's all it took to get this up and running. Now to dig into that, let's actually show another one that's a little more fun that I put together yesterday called Kaleido, where it's all scope-based. If we go down and look at some code, for Kaleido, you can see very similar to JavaScript, all we really have are blocks of codes. So when you're actually executing this, you use it a lot like you use classes or objects. Where you're creating this, I mean, you're calling functions and all sorts of stuff. But under the hood, it's just a block, where essentially it's just exposing the symbol table. And you can see I can have all sorts of stuff where I have an initial capital to get rid of this stuff, replace this with the initial capital, pass in, let's do this value, get rid of that line, go ahead and run this, goes ahead and prints the value, if you can't see that, goes ahead and prints it. Something very simple, not very complicated, and if we actually go and look at how this is implemented, the evaluator for this is only about 35 to 40 lines of code. And you can see all this is making heavy use of pattern matching and tuples and all that kind of stuff, where I found as when I started digging into programming languages, of course, as a .NET developer, I first tried C#. That got really painful really quickly. And as I dove into F#, having the power of things like discriminated unions, tuples, and pattern matching becomes very powerful when you start implementing a language like this to get stuff up and running. If we actually go in, let me show you some of this code. Like what I started off with the expressions, since I'm using essentially discriminated unions, under the hood F#, if you actually run this to reverse engineer this, let's say in a reflector, you'll see that K_expression is a base class. And then we have val, number, string, operator, all that kind of stuff that are derived classes that implement some of that kind of stuff. Well, yeah, of course, I could have done this across 15 C# source files, but that's kind of a pain in the butt. And it's kind of overkill. So actually what I want to do, something that, as I was digging into this, one of the aspects that I love about F#, and it's true with other languages like Ruby and some other languages that we have out there, is this eval loop, where you can very simply just do kind of interactive programming, where you don't write a bunch of code, run it through a program, does it work. you have this interpreter that you're flying stuff into. So normally I would actually use F# Interactive. You notice I'm in Visual Studio. F# Interactive is built into Visual Studio to where I could just do Alt-Enter and send it to Interactive. But right now, at least the build I'm running, there's no way to change the font size. And it's really small, so I just popped out. And I'm going to do it here on the command line where I've been able to do it a lot better. So I'm just going to go ahead and create some of these core objects that I have in my language and go ahead and run them out in F# Interactive so I can get that interactive experience. Do that, and then finally I'll come back and grab my evaluator function that I wrote and go ahead and send that to F# Interactive as well. And then what I love about this is the way that I can really start hacking at the language. I'm going to pull this up. Well, let's say I want to start testing some of the ASTs that I have to see if my runtime is actually responding the way I wish it to. Well, I'm going to go ahead and create a new scope. There's no parent scope. Everything's kind of built around scope, just a simple table, as you all know. I'm going to go ahead and create a scope. And now that I have a scope, I can start evaluating a bunch of stuff where I can be like, eval in this scope, and let's give it an assign node where I'm going to assign to, I'm going to assign to I. Yeah, absolutely. Oops. I'm going to assign to I a value that's a number of 425. Oops. Let's do that again. Assign I value. That's what happens when you run it through like 5 million times and it always works. There's one thing that I've absolutely learned. Let's do value of number. Okay. Of course, now none of it is working. That's the demo. Great. I know why. So I can start throwing stuff. So obviously it returns just the regular number as we expect. And now I know why I failed everyone before. So I'm going to assign to I, and I'll explain why this is actually an array here in a bit. I'm going to assign it the number 4.25. And you can see I actually have a number now in my language, k number, which is, since it's a dynamic language, that's just my runtime interpretation. You can see I can do things like print. So if I want to test that print is actually working, I'll say, okay, I want to print the value of I that I just submitted. And it goes ahead and prints 425 and so on. And let's say I want to assign a bunch of sequences where I can say, okay, there's a sequence of code where I'm actually going to have assign to G. And to G, I'm going to go ahead and assign a string hello. And then I will go ahead and return a string world.
Can you try to bring it up again?
Yeah, I will as soon as I execute this. Oops. So very simply, I was able to say, okay, now when I eval, pass in the AST that's represented by a sequence of expressions that the first one, of course, assigns to a variable this value string and then go ahead and return. So very simple to actually get around and hack a bunch of stuff to make sure that you get everything running and do it kind of piecemeal. Rather than having to worry about having the entire pipeline from your parser to your runtime and everything, hitting F5 for the first time and being like, oh shit, I hope it works. You know, I always love the prayer-based coding where it's just like, okay, throw something there and just cross your fingers. And of course, as developers, we know it never works that way. First time I hit run and it works, I'm just always like, oh, fuck, what did I do? There's got to be something wrong there. So being able to kind of drop into this area and really hack around these kind of things is really fun when it comes to building up stuff. Now, the implementation of these languages behind the scenes, the parser is using some power toys that are included in the F# Power Pack, namely fslex and fsyak. So I do have Lex and Yak grammars that are actually doing the parsing. Once again, this goes back to being an amateur, where the more you learn, the more you realize you don't know. Where the first time it dawned on me is when I tried writing some of my first grammars, and then I go ahead and run them through Lex and Yak, and it's like, yeah, you have 42 shift reduce errors. She's like, well, fuck, I have a lot of stuff to learn. So there's some other directions you can go if you want to do some language-oriented programming with F#. There's a parsec library out there, fparsec, that you can get and actually use. After seeing some ometa# stuff, I'm kind of intrigued to dig into ometa# this week. I think I agree with Alessandro that it's just like, ometa# in a statically typed language. That's got to be interesting. So, excuse me. So as you can see, getting something up and running really quick is very cool with F#. Takes not a lot of work to actually get stuff running, and especially this idea that Eric talks about of going from amateur to expert. One of the things, especially if you're not academically trained, getting up to speed with actually implementing a programming language, you're like, well, great, now I have to learn at least 30 things before I can print hello world. So there's a lot of stuff to learn, and if you really want to dig into the gory details and start getting into type systems, there's an easy way to just suck it up, get down into it, and start applying it right away. And you have all the tools you need to actually do that. I mean, I would consider myself, especially some of you in the room that I look up to, I'm definitely an amateur. And it took, over the weekend. And in some cases with this latest language, with Kaleido, took 4 hours to get up and running with F#. I think that's pretty cool. I mean, I don't know about you guys, but within 4 hours, being able to get a programming language up and running that does all this scope-based stuff that tests out some ideas I absolutely love that element of using F# to actually implement a programming language. Granted, there's a lot of stuff that's not elegant yet. I find myself really inspired by some of the elegant languages out there like Smalltalk and Lisp, where everything's expressed in the language itself. Everything's reified up into the language. Well, obviously, we don't have that yet. Scopes and blocks and everything, they're not reified. They're just a runtime element. And we'll get into that at a later date. But, as far as getting up to speed and just starting to hack shit together, I can tell you it's certainly fun. And I hope that in the long term, tools like this that Luke and his team are doing, I certainly hope will help benefit those developers that want to get up to speed, that want to be the experts 10 to 20 years down the road, or even want to become more experts than they are. The idea of being able to do the interactive programming when developing a language, I know I really love. It's obviously I don't have the years of experience, but man, it's nice and simple to get an eval working. And as you guys all know, every program that you write boils down to a Lisp eval apply function, right? So it all boils down to that and making it simple. So being able to do it itself is really cool. I mean, obviously I can't, with only 15 minutes and with my time basically up, there's not a lot of detail for everyone who hasn't really dug into F#. If you guys have any questions of stuff you want to see about how this stuff was implemented, feel free to ask. Otherwise, that's just it. I wanted to show you some of the stuff that F# makes possible through these tools and interactive programming when designing languages. That's it. Okay. Granted. Thank you.